Let's now look at an example using the remainder and factoring theorem. Recall, we saw that for a polynomial p of x, we have that p of k equals 0 exactly when we can factor out x minus k from p and write p of x as x minus k times another polynomial q. In our example, let's suppose that a little birdie tells you that x equals 2 is a root of p of x equals 3x cubed plus 9x squared minus 18x minus 24. What are the other roots of p of x? In other words, what are the solutions of 3x cubed plus 9x squared minus 18x minus 24 equals 0? Since x equals 2 is a root, the factoring theorem tells us that our polynomial p can be written as x minus 2 times q of x. And we want to solve when this polynomial is equal to 0. So we need to solve 0 equals x minus 2 times q of x. And using the zero product property, either x minus 2 is 0 or q of x is 0. Well, if x minus 2 is 0, then x equals 2. This is the original root that we were given. But how do we solve q of x equals 0? We don't even know what q of x is. But since p of x equals x minus k times q of x, we can rewrite this to find q of x as p of x divided by x minus k. Now we can compute p of x divided by x minus k by using our long division. If you'd like to see the steps of this done out, click the purple link to the left now. Computing the long division, we get that q of x equals 3x squared plus 15x plus 12. Now, we need to solve q of x equals 0, which means that we need to solve 3x squared plus 15x plus 12 equals 0. We can do this using the quadratic formula. If you'd like to see the steps done out, you can click the purple link now. And solving this with the quadratic formula, we get that x equals -1 or -4. So we can conclude that the roots of p of x equals 3x cubed plus 9x squared minus 18x minus 24 are 2, -1, and -4.